Hey everyone, this will be episode number 5 of my Learning Robots, Industrial Robots programming video series. I did finally change my background color, I remembered, so it might be a little easier to look at now. That blue is awful. So what we learned in the last video is how to tell the difference between a joint move and a linear move and why we might want to do those. Linear going right along the path between these points, and joint being more loose and not constraining the robot's path quite as much, but you gain a lot of speed that way. So um, that's about it. If you want to go back, check those out. So what we've done now is basically make a very expensive robot just wave around in space and do nothing because it doesn't really have a tool on it. So normally you would have a welder or a spindle with a mill, end mill or something in it, or a sanding system, or a grinder, or some sort of fixturing gripper, something like that. But we don't have that, and I'm not going to code one up just for the series. We're going to just teach the concepts with some sort of simple tool. So I'm going to go ahead and build one of those. Alright, so let's go over to the modeling tab. This is all within the station. So we need to make a new part for our tool. So I'm not a huge fan of this modeling stuff here. I'm used to systems that are more made for modeling. This will get you by in a pinch or for a simulation, but you should really use something that was made for this. But what I'm going to use is actually, instead of a cone, I'm going to use, just so you will be able to tell the rotation a little better, we'll do a pyramid. This base center point, you need to be careful in this program because it's very involved with the origin of this geometry that you create. And so when you go to attach geometry to other geometry and make it move around and stuff, that origin point, the reference point for that part is very important. That's the attachment point. So I'm going to create this in world 000, and that's where his origin should be. So center to corner point, 150, center to side, that's fine, doesn't really matter. Actually, let's make that about 100. Don't care as much about that. Height, 300, and number of sides, interesting. Create. So there it is, you can see it down in there. See, he's kind of big, but that's fine. He should work fine. So I'm going to close this. I don't want to make an extra one. I'm going to rename him Pyramid Tool, something like that. And then right-click him, attach to the robot. And what it should do is it's asking me, do I want to update the position? If I say no, he's going to be attached to the robot, but he's going to be sitting right here at the base of the robot. So it's going to assume there's some wacky geometry that somehow connects it up, and there's not, clearly. So we want to update that, and now I have this attached to the end of my robot. So what I can actually do, so this, it's worth noting here too that this coordinate system that's showing, that's on the flange of the robot, is oriented with the joint position of that. So we know that pointing out of here is 0, or it could be all the way around and be 360, but either way, it's set up for that. And so that's why, it matches the coordinate system of this one, which is also, perpendicular to these sides here. So that's why it lined it up just perfectly. And so that helps us out a lot. And you'll find with most tools and end effectors, you need to get that figured out. And keep in mind, your tool's orientation to the flange, what the 0 point is. They'll often put a dowel pin or something in there, and it helps make sure that you can get your tool oriented properly here in simulation versus the real world. So just make sure you pay a little bit of attention to that if you are planning to move to real hardware after that. So here's our part, and so now we don't really have the ability to move the tip of our tool with respect to these points. So we can't tell the robot, like, we could come and teach points by looking if we wanted. Like if we wanted to move this guy, come on robot, come with me here. Let's see, let's just move him here, like here for now. If I want to move this guy, now I've got my tool attached, but I can't exactly tell him hey, put this right on this point. That would not be very precise or accurate or anything. So we don't want to just position there. So what we need is for the robot to understand sort of the direction and this point with respect to its flange so that it can then tell what this point is with respect to the world coordinate system. So let's do that. I'll create some tool data for this. So you can usually have as many tools or some amount of tools. I think Fanuc is 10 is the default setting, I believe. And this guy, I think you can have as many as you want, basically. But this concept of creating a tool frame is pretty universal. All right, so we need to create some tool data. If we go back to this Home tab here, we can go to the Other tab and then Create Tool Data. Make it bigger so you can see it. Tool data, we will call pyramid tool data. And robot holds tool. You can have a tool that the robot does not hold if it's on a rotary axis or another robot's holding it, two are working together on it, things like that. So position XYZ. So this is what is the offset, I guess, from this flange is a way to put that. So in this case, from that flange that we mounted this to, I put in 300 for this value to the tip. So I'm going to do that in Z because if you look back at our flange, you can see here's the X marker and then the Y marker. So Z is clearly pointing out of the flange, and we can actually do that. Let's see if I can. Oh, I can just click this right here as well, which is nice. 300, 0, 0. So that works. I'll make this transparent here in a minute to make things easier. Rotation. So if you wanted to actually rotate about this, so say this pyramid was actually mounted in some funky way and sticking off this area over here, we would want to put a rotation about any of our roll, pitch, and yaw, or if you want to do quaternions. But if you just do roll, pitch, and yaw, it works fine. So load data, of course, that's going to be how heavy it is. So the robot actually will change its dynamics and change its collision detection and things like that with respect to the center of gravity, the inertia, and the weight. But since we're all in simulation, we don't need to worry about that. But you will want to do that in a real robot. Storage type persistent, meaning it stays with the controller. And what task is fine, module name is fine. So let's create that, and now we've got a new crosshair here. So that crosshair is now actually our tool data. So you can see over here, tool 0 was our flange, which is the default basic tool. And then we have the actual pyramid tool here is a whole nother set. So what I can do here is I can say now I want to do things. I want to move this robot with respect to the active tool. And so that will let me pick the tool here. He's saying tool 0, tool 1 selected. And so I can now jog about that axis. And so let's see. Okay, and so yeah, clicking on the robot, I guess, is the key there. So I can now rotate the robot about this point, and you can see it's actually, whoops, a little carried away there. It's actually solving the kinematics for the robot to put those positions there. And so now, if I have this, go back to my Home tab, and I've got this pyramid tool data selected as my active tool, go back to my targets and click 1, right click, view robot at target, you can see that now instead of putting the flange at it at this point, like a few videos back, it's actually put the tool right there. And so, if this was a welder and there was some magical part here, we'd have a problem. And so we could just simply come in here, rotate this, rotate it around local, and let's see, that's going to be about the x-axis. So I'll just go 5 degrees, oops, -5 a few times, and we can position this this tool however we want. Now I just crashed the robot there into its own tool, which I shouldn't have made this so big, but that's something valid to watch out for is collisions, because the simulation will happily let you do that. It does have some detection stuff built in that I haven't set up, but just keep in mind you got to be real careful, because the robot will happily try to go there, even though it knows the geometry, it knows the tool. Once I sync this over to rapid, now that I've changed this point, it doesn't really know it any different. it's not part of the things we sync. So, this is about the x-axis, so I maybe need to work on my y-axis a little bit, maybe -5 degrees, and position them how I want. So, alternatively, if you want to, this is how you would, so say I want a whole new point here. So I'll come up, I'll make one up here, for instance. I've now moved the active tool up some, and I can come over here and say teach target, and teach target will target created target 40. So I just made a new target, and I can bounce the robot around between these targets. So if I want to add him to my path, I could easily do that. I'm not going to bother with it. It's pretty straightforward stuff. But so that's similar to how you would do if you're holding the teach pendant, you're jogging the robot. You would go in and say, I want to modify this point, or I want to create a new point, use these coordinates. So let's see, that's about it, what I wanted to cover on tool frames. It's very important for the robot to understand what the tool is, where it, how it faces, how it's oriented, and especially for you in simulation to make sure you're going to orient it right. And if it's a spindle, of course, that extra degree of freedom the robot has in the twisty motion of the spinning spindle, it's kind of annoying. It won't automatically really solve that for you, but you can sort of use that extra degree of freedom to really put the wrist right where you want it for nice linear moves and things. So we'll get in a little bit more tweaking later on in the next video. So stay tuned, and if you're enjoying these, be sure to hit like because it helps me out a lot. Thanks.